Earlier today, I did a chest and bicep workout. I started off with 3 sets of incline Smith machine bench press. Um, I did those basically till failure. Ended up just being 7, 6, and 6, and then I did some incline dumbbell bench press. I did that for another 3 sets. Basically, again, all till failure. Failure. I got 6, 5, and 5. And then I'd finished up with some dips, 3 sets till failure. And then I moved into the biceps where I did 2 sets for each bicep movement. I did some reverse curls, hamstring curls, and single arm preacher curls. And I wanted to talk about how muscle contractions worked for each of those movements. So for example, when I'm doing the Smith machine bench press, I'm going down, my muscle's contracting. The way that muscle is contracting, I've already mentioned earlier the depolarizations and the signals and traveling down the neuron and going through the whole motor unit and how you need multiple motor units for one muscle contraction. Now I'm going to talk about the actual muscle contraction and how those Z discs are moving closer together and how that all happens. So that EPSP that has been released is going to travel, it's going to bind to a receptor on the sarcolemma and travel along the sarcolemma till it reaches the T-tubules, which it'll then go inside, and it will then hit the sarcoplasmic reticulum. Once that depolarization signal, or the EPSP, hits that sarcoplasmic reticulum, calcium is going to be released. Calcium will then bind to troponin to move tropomyosin off actin, to move tropomyosin off actin, so that way myosin can grab actin. Once myosin grabs actin, we have what we call a power stroke, and that is going to be the actual contraction. That's where the Z disc moves closer. That's where we get our force. That's where we get everything we need. And then ATP is going to come in and hydrolyze. It's going to bind to myosin, it's going to bind to myosin, which breaks that cross bridge. So now we get rid of it. That contraction then goes back. And then that ATP needs to be hydrolyzed to where we make ADP and an inorganic phosphate. And then we recycle, we reset, we're ready to bind back to actin. However, tropomyosin is now on the actin, so we need calcium to move troponin, or calcium to bind to troponin to move tropomyosin.